everybody, thanks for checking out the solutions. So this problem 0, like a lot of these problems, is about comparing and contrasting the syntax for arrays and array lists. So here on line 6, you see I'm creating an int array whose size is 1000. And when you create an array, it will allocate the memory for the entire size of the array when you first create it. So what that means is you have to tell it what size it's going to be here between the square braces. And it will actually create the memory locations for all 1000 of those variables when you first create it. When you create an array list, by contrast, you create it empty, and it can dynamically expand as you add things to it. So that's a major difference. Another major difference is here I'm using the primitive data type int. Here I'm using the object version of int, which is a capital I object called integer. We'll talk more about this during the school year. But the important thing to know right now is that array lists cannot use primitive data types. If I say int, can't use that. They've got to be objects. Okay, so, and then one last thing, like I was just saying, for an array, if I was going to display the length of the array right now before adding anything into it, it would be 1000. If I print array2.size, which is the way that you ask an array list what its length is, the size would be 0. Oops. So I don't know if you can see it. It's probably off the edge of the screen here. Let me try and fix this. Well, yeah, so I don't know if you can see my output, but the length of the array is 1000 and the length of the array list is 0. And so in both cases, we want to loop through the arrays and add 1000 random numbers. So here I'm going to use a for loop where I'll go to array.length. A lot of people are using just hard-coded numbers here. Like, we just created it, we know it's size 1000, so let's use 1000. And in theory, there's nothing wrong with that, but it's good to get in the habit of using the array.length if you're actually looping over an array. The reason it's a good habit is because later on, if this was happening in some place in the code that was not right next to where it got created, if I was to change the size of my array later on, I would have to remember to change this loop bound. Otherwise, my code would be broken. But if I use array.length, there's nothing to remember to change, because as soon as I get to the loop, I ask the array how long it is. So there isn't this hard-coded dependency between the for loop, between like the number here and the number there. I'm asking the array itself. So let's say array location I gets math.random times 10. So that's a random number now between 0 and 9. And when I add 1, now that whole range from 0 to 9 has shifted to be 1 to 10. So you might think that you could do that same thing over here on the other side. Here, it doesn't work to say array2.size because, of course, array2 is empty right now. So here I really do need to say 1000, because each time I add something to array2, it's going to dynamically expand. And instead of using the square bracket notation, which only works for arrays, I'm going to say add. But this part's going to be the same. So I'm going to add this much. And that's it. For problem 1, it was about a deck of cards. And the wording, I think, was maybe a little bit weird. Some people did some weird stuff that I think was about not understanding what I was asking. But the idea is I want an array list of integers that represent the values of all of the cards in a deck of cards. So I'm going to call it deck. That seems like a sensible thing to call it. There's a lot of different ways to do this, but the idea is the values in a deck of cards range from 2 up to 14. So like you could have a card that has a number 2 on it, or if you have a card that's 11, that's what I'm calling a jack. 12 would be a queen, 13 would be a king, and 14 would be an ace. So I'm going to loop values from 2 up to 14. But then, for each value, I want to add it 4 times. So one thing I could do would be say deck.addVal, and I could just copy this 1, 2, 3, 4 times. So now I'm adding 4 copies of each card. A different thing I could do would be to use a loop. I would say, oops. I would say it like this. So I'm going to loop 4 times, and then I'd say dec.add val, like that. And that would work. If you wanted to reverse the order of these, you could also reverse the order. The way that it is right now, when val is 2, I add 4 copies of that number 2 in a row, and then I go and increase the value, and so now I have a value of 3, and then I add 4 copies of 3 in a row, and so on. If I was going to reverse the order of these 2 loops, like this, now I'm going to loop 4 times, but each time I loop, I'm going to loop through all of the values. So this is going to end up with the same collection of cards at the end, but in this case, I'm adding all of the values 2 through 14, and then I'm going back and I'm doing it all over again, and I'm adding all of the values from 2 to 14 a second time, and so on. So those are all totally adequate ways of doing it. And then at the end, I told you about the existence of collections.shuffle, which will randomize the order of the elements in a list. Problem 2 is something that we do a lot of. It's selecting a random element from a list. So in this case, we're selecting a random name, a random adjective, phrase, and we're combining them together. So I'd said create an array, which we'll call maybe phrases, and it's going to be length 100, and that was something that I said in the problem. Now let's loop over it. So we're going to loop from 0 to phrases.length. And now I need to get some random phrases. So let's do this. Let's say name equals, and then I'm going to use the names array, and here I would put the index that I want to access, so like names 3 or something. What I've seen a lot of people do, which again isn't wrong but is fragile and not the best approach, is to like look themselves. They say, how long is the names list? Oh, 1, 2, 3, 4. So I'm going to put 4 right here. The problem with that, again, is if I was going to add another thing here, now its length has changed, but I might forget to change this number to 5 down here, and if I forget, now my code is broken. So it's best to write your code in a way where you have to remember as little as possible in order for your code not to break if you're going to change it or extend it in some way. So the better thing to do is to use names.length. We're going to talk more about this during the year, but if you were going to use a hard-coded number like this, like 4, that's called a magic number. And that's magic is bad in this case. And the reason it's called magic is because another programmer might look at this 4 and think, why 4? That seems like a very specific value. And maybe they'd read your code and figure it out, and maybe they wouldn't. But there's no question at all if I say names.length, because now we know what this part actually means. So let's do the same thing. Adjectives equals, what do I call it? ADJS. And then int math.random times adjectives.length. Cool. So now I am getting a random element out of each. I can't, so let's call this adjective. And now I'm going to say phrases I equals name plus, and then a space, and then adjective. So now I'm putting together my 2 random selections. What does it not like here? Did my parentheses get messed up somehow? No. Oh, it's not a method. Great. And if I was just going to print phrases, that would print the memory location where the phrases array is created. So instead, I need to say arrays.toString and then give it my phrases array. Okay. Problem 3. So this was the one that most people had questions about. Before we do the solution, let's just remember how to think about this. So the idea of a numerical interval is pretty common both in math and also, in everyday life. So I might say, like, choose a number between 3 and 9. That idea of the range of values between 3 and 9, that's an interval. That's a numerical interval. Choose a number between -2 and 100. That's a numeric interval. So the idea is, if we weren't using objects, you could use a variable to represent like what this minimum value is and what the maximum value is, if you wanted to represent the idea of this numeric interval. But we're going to use that same idea, except that we're going to make an object out of it. So instead of representing the interval with two separate variables, we're going to encapsulate those two variables inside an object that we're calling interval. So if I wanted to represent the interval from 3 to 9, you could say new interval from 3 to 9, and that would create an object that represents the interval. So let's do that much, and then we'll look at what we're going to do with them. So here I am making a new Java class, interval. Something that people are still not in the habit of yet is making sure that all of your fields are private. So I'm going to call this maybe min and max value for the interval. If you're not doing this, you can auto-generate your constructors by doing Control-Shift-A and then type the word constructor if you want to. If you're still not comfortable with the syntax for constructors, it's probably a good idea to type it out yourself every time just to get the practice. But if you're good, then you can auto-generate them like this. So I've got my constructor. Same thing, you can auto-generate your getters and setters like this. All right, so now I've got an interval class. Here I am back in main. So if I wanted to, so let's make an array list that can hold a lot of intervals. So an array list, and now that I've defined the interval class, that defines, wow, I can't type and think at the same time. Interval, okay, so that defines an interval object, which I can use as a data type. So this is going to be a list of intervals, which I will call, creatively enough, intervals. And then if I wanted to add one, I could say intervals.add new interval, and then I could make an interval, say, from 2 to 8. And the idea is that's going to now represent the range of values from 2 to 8. So I'm going to write the rest of the solution now in the way that I think is the most straightforward, but then we're going to make a couple of minor improvements to make it the best possible answer. So I'd said we're going to make 100 random intervals. So let's loop from 0 to 100. Let's create an interval. Well, let's create our random numbers first. So math.random, and then what did I say it was supposed to be between? I think 0 to 400 maybe, 499. So there's the first one, or maybe I said I didn't care. All right, so now I've got two numbers. I can't just do this though. If I say interval, new interval like this, AB, the problem is there's no guaranteeing that A is a smaller value than B. And the way that the interval object is defined, it's important that this first input is a smaller number than the second input because it's going to get saved into this min. So if it's not, if B is actually smaller than A, then our names will be all wrong and it will lead to bugs in the future. So one solution to this problem would be something like this. We could say if A is less than B, let's do it this way. Otherwise, let's do it the other way, B comma A. So that's like a totally reasonable way to approach it. Some people did a loop where they continually generate these random numbers until A is smaller than B. And that's okay, but it's a little bit wasteful because you don't want to throw away random numbers just because they're kind of saved in the wrong places. My favorite solution here is this. Let's do it this way. So I'll say, I don't know why I made these doubles. So let's do them this way. You can use math.min to actually get which is the smaller of the two. You can use math.max to get which is the larger of the two. And then when you create your interval, you can use small comma large because you've now assigned the correct random values into variables where you know which one is large and which one is small. So to me, that feels like the cleanest solution. So after I have 100 random intervals, now we're going to ask the user to choose a number between 0 and 100. And I guess let's do this. I'm going to call it target. Let's use JOption pane actually. So I'm going to do double.parseDouble, and then I'm just going to nest the JOption pane right in there. Okay, great. So I've got this target double now, and I'm going to, so if I wanted to use a regular loop, a regular for loop, I could do this. I called it intervals, right? So intervals.size. And then if I wanted to get out an interval, I'd say intervals.getI. And so now this is looping over each location, and for each location, I'm getting the interval that's saved in that location. A shorter way of doing this exact same thing is to use a for each loop, which looks like this. Just like a for loop, there are two sections. There's the section, well, sorry, a normal for loop has three sections that are separated by semicolons. So you've got the section where you create the starting value for your location number, and the test to decide whether you should keep looping, and then how you should change your index each time. For a for each loop, there's two sections that are separated by colon. So this first section is where you're going to define a variable that can hold the values from your list. So I've got a list of intervals. So here I'm going to declare an interval object. Interval, and I'm going to call it in for interval. So this syntax is the exact same thing as if I was going to say like int n or like string name. You see how it's got the same form? I've got data type and then variable name. So that's what I'm doing there. I'm defining a variable that's going to hold the members of my list. And then on the right-hand side of the colon, I'm going to give it the name of my list, intervals. And so this loop now is doing the exact same thing as the one underneath it. What happens is this loop will automatically loop over every single location in this list, and one at a time it will assign each value to this variable in. So this is called a for each loop, because a good way of thinking about it is for each value in this list, do something. And what I want to do is I want to test to see whether the user's target value is inside that particular interval. So the way that most people did it was something like this. We'd say in.getMin, and we want to make sure that's less than or equal to target, and that target is less than or equal to, in.getMax. So if that's true, then we're going to display the interval. Okay, so in order for this to work, I would actually have to define a toString inside interval, which I haven't done. So let's go ahead and do that. By the way, you can automatically generate toStrings also if you want to. Ta-da! So that was fast. So now it's going to display properly. Let's just run it and see what it looks like. So I'm going to choose, I don't know, 45. And it apparently had nothing in it that was in that range. I wonder why. That feels like a bug. Aha. So I didn't actually, so I'm looping I'm looping 100 times here, but I never actually add the interval to my list at all. Cool. So intervals.add interval, great. And it's actually a little bit silly to have a separate line here for this. Like I might as well just put the constructor call directly inside like that. Seems a little bit nicer. Okay. So let's do two minor improvements here. Part of the idea of creating objects is for them to be smart enough that they can answer questions about themselves and handle any changes that are required to their own data. So this code right here is a question that we're asking about the interval. We're saying, hey, interval, do you contain this target value? So rather than pulling out the min and max values so that we can construct our own test, it's probably better if we can put this question as a method directly in the interval class itself. It would be better to be able to ask, hey, interval, do you contain the target value? Contains is not a method in my interval class, but let's go ahead and create it. So here I'm creating it. It jumped me over to interval here. Oops. And now I can return whether this interval's minimum is smaller than the target, and the target is smaller than this interval's maximum. So now I've created the ability for intervals to answer the question for themselves whether or not a certain number falls within their range. And so that makes the code out here a lot cleaner. So this is a pattern we're going to see a lot in this class, is moving different parts of the code around to make your code more flexible, easier for other people to use, more readable, more maintainable, things like that. So the last thing that I wanted to do was change the way the constructor works. So a lot of people did great jobs of figuring out how to enforce that the first number is smaller than the second number when you create a new interval. But the problem is, let's pretend you'd forgotten to do that, or you're going to give your interval class to somebody else to use and they forgot to do that. Or let's say there's a bug in your code up here. If you happen to pass two inputs that are in the wrong order, your interval will just silently accept that. So what would be a little bit better is let's cut this from here and let's move it inside the interval class itself. So I'm going to call this A and B. And inside the interval constructor, let's go ahead and, what is the problem here? Oh, so inside the interval constructor, let's go ahead and do the code that will enforce that we're assigning the right things to the right places. Or even shorter than this. Let's do it this way. So it's the same code, but now it's in the constructor. And what this means is it's harder to misuse this object. Like if someone passes in a first input that is actually larger than the second input, our object will silently correct it when it gets constructed right in its own constructor. So that makes our object like a little bit less fragile, a little bit more robust. And like that also means that out here we can be a little bit lazier if we want to be. I actually don't recommend that practice. I still recommend trying to do it on this end also. But you could be if you wanted to, because we've made our code robust enough that it could still accept the other approach. Okay, I hope that was helpful. Here is a solution to problem 4. The goal is to write a method that returns true if an input list does not contain a 2 or a 5. So the logic of what we're going to do here is we're going to loop over every value in the list, and if we ever see a 2 or a 5, then we know that it is false that it doesn't contain one. So if we ever see a 2 or a 5, we can immediately exit by saying, nope, not true that our list doesn't contain one because we saw one. However, if a particular element is not a 2 or a 5, that means we have to keep checking. We have to go to the next element and check that one. So if this if statement isn't true, then we'll go back to the top and we'll keep looping. And only when we've checked every single element in the list can we confidently say, yep, I'm sure that the list doesn't contain those values. Because until we've checked all of them, there's still the possibility that maybe one of the ones that we didn't check is one of those forbidden values. So that's the kind of way that I think is nicest to think about it. A lot of people were doing things where they were using a counter, where you like count how many values are not 2 and not 5. And then at the end you say, if the counter is the same as like all of the values in the list, then we'll return true. And that method works, but it's a little bit less clean than this. And it's also a little bit less efficient because you have to loop to the end of your list no matter what in order to return. Whereas here, if you have a list whose length is 1,000,000 elements, but the first element is a 2, this method would return immediately. Whereas in the other approach where you're using a counter, you would still have to loop through all the 1,000,000 elements, even though you'd know right away after the first one that you're going to return false eventually. So now let's bring out sort of the compare and contrast. So here we've got an int array. Here we've got an array list of integer. The only real difference here is how you get the thing out of the list and how you ask the array how long it is. So here we've got array.length, list.size, and then here you use the square bracket notation, and here you use .get. Other than that, the logic of what the methods are doing and the structure is exactly the same. Okay, problem 5 is 2 versions of the duplicate neighbor, and the idea is we want to know whether an array or an array list contain adjacent elements that are the same. So there are 2 bugs in each of these methods. Take a minute and look at them if you want. So the first bug, IntelliJ is actually highlighting for us with this double equals. Let's see what it says when I mouse over. String values are compared using double equals, not dot equals. Thanks, IntelliJ. So right, we'd said before that when you're using strings, you have to use dot equals. Good thing to get in the habit of doing. And we'll talk a little bit more during the year about why that's true and what it means to use double equals for strings. But for the moment, that was the first error. The second error is if you run this code on any input at all, it's going to go out of bounds. And the reason why is because here and here, I'm trying to access the location at I plus 1, but in the loop, I have I go all the way to the end of the list. So what I have to do is I have to make I stop one location before the end of the list. So a lot of you know already that list.size minus 1 is the last valid location. So here I'm saying I has to be smaller than the last valid location. And that's safe because if I go 1 past that, now I'm at the end of the list, the last valid location. So checking your loop bounds like that is super, super important. I am going to repeatedly trick you with this, and it's not because it's not me, it's that programs will repeatedly trick you with this. It's just like a natural part of programming. It's so famous, actually, that there's a name for it. It's called an off by 1 error, because you're off by 1 in how far you thought that I needed to go. So like load that in your mind as something that you need to check all the time whenever you're looping over a list of anything. Last problem is testing for equality. Again, these 2 methods have the same structure, but the way that you do particular things is slightly different. So for array lists, you have to use size. For arrays, you use .length. For array lists, you use get. For arrays, you use the square bracket notation. There's still a bug here, which is not equals is similar to using equals equals. So because we're using strings here, if we're going to use not equals, what you have to do is you use dot equals like this, but we want to say not that. We want to say not equal. So you have to put the negation operator, the bang here, at the front. And the same thing here. Not true, oops, sorry. Not true that A element I dot equals B element I. Okay, and now the code has been fixed. I hope this was helpful. If you have any questions, please for sure email me or put them in Google Classroom or even, post them as a comment in this YouTube video. Thanks so much.